Hello, and welcome to a video about the Unit 3 review. Alright, let's get started. Dax pays $65.99 plus 35 cents for each minute over $4.50 for his cell phone plan. Monica pays $54.99 plus 20 cents. Plus 20 cents for each minute over $4.50. Which system represents this situation? And let's have X represent the number of minutes over $4.50. Okay, so let's take a look at Dax. Dax pays $65.99 no matter what. So what we're going to look for is a system with $65.99 without any X's next to it, because $65.99 cannot change. Dax has to pay it. I see that happening in letter C and in letter D. So I know for sure I can cross off A and B. Now Dax also pays plus 35 cents for each minute. So it should have 35 cents for each minute. And remember, each minute is X. So it should have 0.35X. So let's take a look. Does C or D have that? Letter C has that. Unfortunately, letter D has it with the wrong amount of money. So letter C is our correct answer. All right, number 2. How many solutions do each of the systems of equations have? Now in letter A and B, we can go into our calculators if you're using those graphing ones that we have in class. You can click menu, then the 3, a 2, enter. You put in your equations and then enter again. You will get your number of solutions. Now what we can do instead, if we're doing this by hand, is get both equations as y equals and take a look at their slopes and y-intercepts. So I'm going to first do that with this top equation, and then we're going to use the bottom one. All right, so let's get y by itself. First, I'm going to subtract 3x from both sides. So I have negative y equals 1 minus 3x. And then I'm going to divide everything by negative 1 in order to get y to be by itself, just positive. So y equals negative 1 plus 3x. All right, let's do the same thing with the bottom equation. So I'm just rewriting it for myself. I'm going to begin by adding 9x to both sides to move it over. So I have 3y equals negative 1 plus 9x. And then to get y by itself, I'm going to divide everything by 3. I made that a little too large. Let's make it smaller. There we go. All right, so 3 divided by 3 is 1, so 1y, negative 1/3 plus 3x, because 9 divided by 3. All right, so let's take a look at these two equations. What we need to look at first and foremost is their slope. Here we have a slope of 3. Okay, so they have the same slope. Will they cross at all? Let's see, based on their y-intercept. This one has negative 1/3. This one is negative 1. These are actually going to be two parallel lines. This is no solution. So if they have the same slope but different y-intercepts, no solution. All right, onwards we go. Let's do the same thing with letter B. Oops. All right, there we go. So just like in letter A, you can plug this into your calculator, following the steps of clicking menu, then a 3, then a 2, then enter, putting in both of your equations and clicking enter again. Now, in letter A, if you did that, your calculator would quite literally say no solutions. So you would know right away without having to do the legwork on your own. But let's say again for letter B, we don't have our calculators present. How would we do it? We would get both of these into y equals equations, just like we did in letter A, and we'd take a look at their slopes and y-intercepts. All right, I'm just going to rewrite this one. Okay, I'm going to begin by subtracting 6x to both sides. So I have negative y equals 1 minus 6x. And then to get y by itself, I'm going to divide everything by a negative 1. Okay, so we're left with y equals negative 1 plus 6x. So there's our first equation. Now let's rewrite the second one. Since we have a minus 18x, I'm going to start by adding 18x to both sides. They cancel here, so we have 3y equals negative 3 plus 18x. And I'm going to finish by dividing everything by 3. So let's see what we end up with. Y equals negative 3 divided by 3 is negative 1. 18 divided by 3 is 6. We end up with this equation. So let's take a look at their slopes and y-intercepts. Well, these happen to have the same exact slope. All right, let's see how their y-intercepts look. The y-intercept here is negative 1, and the y-intercept there is negative 1. You may have even noticed that these equations are exactly the same, which means we have infinite solutions. That's my attempt at infinity sign. Or of course, you can just use the words infinite. If you had entered this into your calculator, you would get a weird answer. You would have like a C1 or a C2 is what our calculator presents. Maybe C with some other number. That's what says infinite in our calculators. That's what it means. All right, number 3. Solve the following system by linear substitution. Okay, let's do it. Substituting is asking us to do this. We're going to take this y and we're going to plug it into that top equation. So instead of 3x plus y equals 5, I'm going to have 3x plus 5x minus 19 equals 5. Now usually I put in parentheses around there, but that's when we have a number in front of the y. In this case, we don't have any numbers in front of the y, so I could just leave it as 5x minus 19 without any parentheses around it. All right, let's combine some like terms. We can combine the x's. 3x's and 5x's give us 8x's. Then my next step would be to add 19 to both sides to undo the minus 19. And of course, I made this too large. Let's try that again. That's better. All right, I don't know why it selected that large of an area, but it is what it is. That was weird. That was weird. Let's move you over here where there's more space. There we go. Okay, so adding 19 to both sides to undo the minus 19. So we have 8x equals 24. And of course, we'll finish by dividing both sides by 8. So x equals 3. Now that we found x, we can plug it back into our y equals equation to solve for y. So y equals, instead of 5x minus 19, I'm going to plug in that 3. So I'm taking that 3 right here, and I'm plugging it in. All right. So y equals 15 minus 19, which means y equals negative 4. So our final answer is 3, negative 4. Don't forget, we're always keeping it in alphabetical order, x, y. Yes, you can plug this into your computer as well, and into your computer, whoops, I meant calculator. You can plug it into your calculator and get your answer. Of course, I won't be able to give you points for showing your work, but I can give you a point for the correct answer. Using your technology right is also important. All right, number 4, you get an option of solving this whichever way you'd like. Again, you can use your calculator to solve this, but I can't give you full credit if you just give me an answer. Now, the way I would solve this problem is by elimination, because I notice a positive and a negative y. So this is what I'm going to do. I'm going to multiply the whole top equation by 9 and the whole bottom equation by 6. Now I'm keeping both of these numbers positive because my y's already have one positive, one negative. I don't need to create that. All right, let's see what happens. 9 times 3x is, it's not 18. I don't know why I wrote that. It's 27. 27x. 9 times 6y is 54y. 9 times 33 is 297. Yes? Yes. Yes, okay. Just double checking myself. All right, onwards we go. 6 times 6x is 36x's. 6 times negative 9y is negative 54y. And 6 times 18 is negative 108. Now, check out what happened with our y's. We officially have opposites. Wonderful. They cancel. Now we can add everything going up and down. 27x's and 36x's, if I add that together, I get 63x. And 297 plus 108 is going to be 189. And I'm going to finish this problem by dividing both sides by 63. X equals 3. Wonderful. Now it doesn't matter which equation we plug it back into. I feel like plugging it into the top equation. So instead of 3x plus 6y equals 33, I'm going to plug in a 3 in for x because we found x. Once again, I need to move this over here. Let's make it a little smaller so I can fit everything in. And of course, let's color code a little bit. This x equals 3 is getting plugged in right there. All right, let's simplify. 3 times 3 is 9. I'm going to subtract 9 from both sides now. So 6y equals negative 6. And I finish by dividing by 6. Y equals negative 1. So our final answer is 3, negative 1. All right, onwards we go. Number 5, another problem solving through linear combination / elimination. Like I've stated in numbers 2, numbers 3, and number 4, you can plug this into your calculator using your menu 3-2 option. I won't be able to give you full credit for a problem on the test like that, but at least I can give you a point for having the correct answer. Using technology correctly is still very important. All right, let's do this. Now, we could either get rid of the x's or the y's. It doesn't really matter because both of them I see one negative, one positive. In my previous problem, we did the y's, so let's just, for funsies, let's do x's this time. So since one's positive, one's negative already, I'm going to multiply the top by positive 5 and the bottom by positive 4. All right, let's see what we get. 5 times negative 4x is negative 20x. 5 times 1y is 5y. 5 times 17 is 75. No, 85. My bad. Okay, let's do the bottom. 4 times 5 is positive 20x. Plus, oh, not plus, minus. My bad. Minus. 4 times negative 6 is negative 24. That's why it's a minus. Equals 4 times negative 7 is negative 28. Our x's are officially opposites. That was the point. Let's add everything going up and down. Our x's cancel. Wonderful. 5y plus negative 24y is negative 19y. 85 plus negative 28 is 57. And we'll divide both sides by negative 19. And our answer, y equals negative 3. All right, wonderful. We have y, so let's find x. To me, looks like the top equation might be a little easier to use, so I'm going to rewrite the original, and I'm going to plug in what we got for y. And let's use yellow for y, because why not? Okay. So, to undo that minus 3, we're going to add 3 to both sides. Wonderful. Negative 4x equals 20. And we divide both sides by negative 4. X equals negative 5. So, our final answer here is negative 5 comma negative 3. Remember, we're always writing x's and then y, so we're keeping this in alphabetical order. Okay. Number 6. Given each system of equations, choose which would be best. And let's explain why we chose. So letter A. For letter A, I would choose linear combination / elimination because our x's are opposites. And check it out. We have a positive 10x and a negative 10x. So if we added them going up and down, the x's would cancel. Everything would turn out beautifully. Letter B looks like it would be better with substitution. Because one equation is y equals. So since we have one equation that's y equals, that means I could take it and plug it into that bottom equation, solve for x, and then find y after that. Lastly, letter C would best be with graphing because both equations are y equals, which means we can just plop them into our calculator, graph them, see where they intersect. It's just way easier to plot something in our calculator if it's a y equals equation. We'll see where they intersect. We have our answer. Okay, onwards we go to number 7. The graph of which inequality would be best represented, just represented, with a dashed line. All right, well, the inequalities that are represented with dashed lines would be a symbol like this or a symbol like that. So let's find them. Letter A has a symbol like that, and so does letter C. The way I remember this is solid lines on a graph are represented with solid lines in our inequality. So if you look at letter B and letter D, both of those symbols have a solid line underneath. So if it's dashed, it does not have a solid line underneath it. All right, number 8. Write an inequality represented by the graph. So when we're writing an inequality represented by the graph, we're looking at a y, some symbol, and then mx plus b. All right, so let's check it out. First, let's decide on our symbol. This is a solid line, which means our symbol will have a solid line. Now, the way I decide which way my symbol points is by placing my pen or pencil on my solid line, anywhere on it, and then I'm going to drag my pen or pencil either up or down, and I want to drag it towards the shaded area. In this case, I would be dragging it up towards the shaded area. Up means greater than. So y is greater than or equal to. Now let's find our slope. We can find our slope by using 2 points on our graph. And we're always going from the left point to the right point. So it looks like we're going down 1, 2, 3, and to the right 1. If we're going down, that means it's a negative 3/1. And B is our y-intercept. In this case, our y-intercept is right here. It's 4 plus 4. And that's it. Number 9. Select all the points that are solutions for the system of inequalities. So the way we find our solutions is by plotting these points and seeing where they land. Let's do it. Letter A, -2, -2. -2, -2 ends up as a point right here. It landed on a solid line that is part of the shaded area. So this one is part of our answer. Letter B is 0, 1. 0, 1 lands right here. Unfortunately, that is a dotted line in the shaded area. So this is not one of our answers. Dotted lines are not or equal to's. We cannot equal our dotted line. Letter C, 4, 1. Well, 4, 1, it lands on the solid line. However, it's not a part of the shaded area. So no, letter C is not a part of our solution. Letter D, 1, 4. 1, 4. Well, that's not even on any line. That's not even in a shaded area. So absolutely not. Lastly, -3, 1. Oh, beautiful. Letter E falls directly in the middle of the shaded area. Number 10. Which system of linear inequalities represents this graph? Well, let's find out. We've got 2 lines. That means 2 y's. Now we're going to decide which way our symbols point. I'm going to start with the solid line. I'm going to put my pen on my solid line, and I'm going to drag it either up or down towards the shaded area. And it looks like I'm dragging my pen going up. That means one of my inequalities will have a greater than or equal to. I know it has an or equal to because it's a solid line. It's greater than because it's shaded up. Now let's take a look at the dotted line. If I put my pen on the dotted line, I would have to shade down to get to my shaded area. So we also have a less than. So let's look for the letter that has both of those symbols. A does not. B doesn't. C does. And D does not. Okay, perfect. We have letter C. Number 11. Jose wants to rent a boat. He has no more than Y dollars to spend. Fun Boats charges an initial fee of $200 plus $10 per hour. Boat Life charges an initial fee of $100 plus $15 an hour. Let's write a system of inequalities, and X will represent the number of hours. So first let's decide, can Jose spend more than Y dollars? The answer is no. So Jose has to spend greater than Y dollars. If Jose felt like it, could he spend all of his money? Sure, why not? So they both get an or equal to, because he could spend it all. All right, Fun Boats. Fun Boats charges $210 an hour. So no matter what, Fun Boats you need to pay $200 plus $10 an hour. Boat Life, you have to pay $100, and then you pay $15 for each hour you spend using the boat. Okay, we're not solving, we're just writing. So on to our last problem, number 12. Let's complete this system of inequalities represented by the graph. Okay, let's get started. Now, what I like to do, what I like to start with is I like to find my vertical or horizontal lines. In this case, I do see one vertical line. It's this one right here. So vertical lines are X lines. So that matches up with my last one right here. It's a dotted line, so I know it won't have a symbol underneath. It's shaded to the left, so x is less than 4. Okay, now let's figure out the rest of the lines. Since they're all diagonals, we don't have any horizontal ones to look at. We're going to look at our y-intercepts. That's how I determine which line is which. So the first one has a y-intercept at -3. So let's find which line goes through -3. It looks like it's this one right here. So I'm going to color that in so we can see it. All right. So that line is dotted, so it won't have a line underneath its symbol. And which way is it shaded? Well, if I put my pen on it, I drag my pen upwards, so it is greater than. Okay, next. This one has a -6, so which one crosses -6? Looks like this one does. Beautiful. Okay. This one, let's see which way it shades. If I put my pen on it, I have to pull upwards. So this is greater than. Since it's a solid line, it's greater than or equal to. And of course, we only have one line remaining. Let's decide which way it's shaded. I'm going to put my pen on the line, and it goes down. So this one's going to be less than. And since it is a solid line, this is going to be less than or equal to. All right, that's about it. If you have any questions, please don't hesitate to ask me or your teachers about it. Happy studying. Have a wonderful rest of whatever day it is for you. Bye.